Alright, so now, the last part of 5.5 and 5.6 before we do lots and lots of in-class practice is, once again, working backwards. And something to remember when we are getting ready to work backwards, you have to remember that all imaginary and irrational roots, they always come in pairs. Okay? Think about it. When you do the quadratic formula and you get an I in your answer, it's always going to be plus or minus the I. So your imaginaries always come in pairs. You only get an answer like this from the quadratic formula where you have plus or minus, or completing the square and you've taken the square root of both sides and you still get plus or minus. So anything that looks like this, that is an irrational root, it always comes in pairs as well. So when I'm looking here and they want me to write the polynomial in standard form that has these roots, you've got to remember that these are not the only roots. This one comes in a pair. You also get 6 minus 2i. The 2, it's not imaginary, it is not irrational, it does not have to come in a pair. So these are my roots. I'm going to work backwards with those. I know that x equals 2, x equals 6 plus 2i, and x equals 6 minus 2i. I have to get back to the equation. So just like we did in the first half of the chapter, we're going to move all of this stuff back over on the same side with the x so I can put them in parentheses. So this one is going to give me x minus 2. For this one, when I move the 6 over, it becomes minus 6. When I move this over, it becomes minus 2i. For this root, when I move the 6 over, it becomes negative. When I move the 2i over, it becomes plus 2i. Now, in order for this to be an equation, it's got to equal something. So it either equals 0, or it equals p of x, or f of x, or y. It has to equal something. And now we've got to multiply these back together. So I would start with these. Okay, it's a little bit more work, but it will get rid of my imaginary parts of this problem. So I'm going to start out multiplying this x times everything over here. So x times x is x squared. X times negative 6 is minus 6x. And x times 2i is plus 2ix. Now I'm going to distribute this negative 6 to everything over here. So that will give me negative 6 times x is negative 6x. Negative 6 times negative 6 is a positive 36. I put it out here because I don't have a like term to put it under. And then negative 6 times a positive 2i is a negative 12. Oh, that can't go there. That gives me a negative 12i. And it doesn't have a like term. So it's going to go out here. Next, I have to distribute my negative 2ix to all of these. So negative 2i times x is going to give me negative 2ix. Negative 2i times negative 6 is a positive 12i. Negative 2i times positive 2i gives me a negative 4i squared. So let's combine all of those like terms, but don't forget you got to bring this down. So I end up with x squared minus 12x. These will cancel. Plus 36. These will cancel. And this term, that is negative 4 times negative 1, makes that a plus 4. So what I have now is x minus 2 times x squared minus 12x plus 40. I have to multiply those together. And I'm running out of room, didn't really leave myself enough space, so I'm going to put my results over here. So let's start out distributing x squared times everything over here. That will give me x cubed minus 12x squared plus 40x. And now I want to distribute my negative 2 to everything over here. So that gives me negative 2x squared plus 24x minus 80. Put my like terms together. I get x cubed minus 14x squared plus 64x minus 80, and it's got to equal something, so I set it equal to y. This is your equation. Right? Now we've got one more of those. I want to help you get it set up, and then I'm going to give you a minute to work it, have you pause the video while I work it, and then you can come back and double check it with mine. Okay? This negative 4 is not imaginary, it is not irrational, so it doesn't have a pair. So x equals negative 4. This one, however, is an irrational root, so it also, or it should have a pair, so it also has 3 minus 2i. So I'm going to set up x equals 3 plus the square root of 2, and x equals 3 minus the square root of 2. Move it all back over, so I end up with x plus 4, x minus 3 minus the square root of 2, and x minus 3 plus the square root of 2. And now multiply it all together. Go ahead, pause the video while you multiply it. When you're done, turn it back on. You can check your work and your answer with mine. I'm going to start here. Alright, so here is my work for that first part. Let's double check and make sure you got it correct. I started out by distributing this x to everything here, and that's where this line came from. I did that first. Then I distribute my negative 3 to all of those. That's where this row came from. And then I took my negative square root of 2, multiplied it by all of those, and that's where this third row came from. Combined my like terms, gave me this. Had some like terms in my parentheses that I put together, and now I'm here. Now I have to multiply x times all of those and 4 times all of those. Okay, if you're good up to here or you need to fix something, go ahead, pause the video, go back and fix it, or continue working from here. And I'll be back in just a second to let you double check. Alright, so there I have finished it. I multiplied my x times everything in this parenthesis. It gave me this first row here. Then I distributed my 4 to everything in this parenthesis. It gave me this next row here. Combined all my like terms, and this is the polynomial in standard form that has these roots. Okay, and that is it for 5, 5, and 5, 6.